Chapter 5 Review. First, we're going to put in vertex formula. The vertex form is y equals a parentheses x minus h quantity squared plus k, where the vertex is hk. Remember that the vertex is the opposite of h inside the formula. So you have the equation 3x squared minus 12x plus 13. We are going to complete the square with just the first two terms. Normally when we were completing the square, we would move and it was an equation not equal to, if it was equal to 0, not equal to y, we would have 13 on the other side. But when we have it equal to y, 13 stays on the same side. So it's a little different. So we first are going to factor out a 3 from the first two terms. Now we're going to complete the square by taking half of 4, square it is 4. So instead of adding 4 to both sides of the equation, we are going to do the opposite. But we also have to multiply the 3 times the 4 and get 12. So we're going to do the opposite. So we are going to subtract 12. Now that is a perfect square trinomial, which is x minus 2 quantity squared plus 1. So the vertex is the opposite, so that's 2, 1. An extra point, you can pick any point you want. I'm going to pick 3. You could have picked 4, 5. You could have picked 2. Well, no, not 2 because 2 is the vertex. You could have picked 1. You could have picked 0. You can pick anything you want. I just happen to pick 3. Plug it in, and you get the ordered pair 3, 4. Find the corresponding point is 1, 4. Now another way you could check by finding the vertex using the formula x equals negative b over 2a. This is a way that you can check to make sure that you put it in the vertex form correctly. So when you do that, you get x equals 2, plug that into the equation, and you get y equals 1. So that is the vertex 2, 1. Number 2, we're going to again put it in vertex form. So there's the vertex formula. We are going to factor out a negative 1 just from the first two terms. Then we're going to complete the square by taking half of 4, squared is 4, so we're going to add 4 to both sides. Now, we have to multiply the negative 1 times the 4 and get negative 4, so we're going to do the opposite, so that will be minus a negative 4. That's a perfect square trinomial, which is x minus 2 quantity squared, and we get negative 1. So the vertex is the opposite of h, so that's 2, negative 1. The extra point, an easy extra point would be your y-intercept, which is 0c. So that's 0, negative 5. I'm going to let you finish. Now, again, another way you could check to make sure you found the vertex correctly is use the formula negative b over 2a. Back into the original problem. So x is equal to negative 4 over 2 times a is negative 1, so that's negative 2, which is positive 2. And that is what we have for the vertex. You could plug 2 into the original equation to find y. That's just another way to make sure that you did the vertex form correctly. Okay, I don't know what all that is. Okay, here we go. We're going to list the factors of 6, list the factors of 2. We're going to guess and check. It's negative 8x. It's not negative 13, so we're going to flip the 2 and the 1 around. Check. That didn't work, so now we're going to use the 6 and the 1. That checks. Number 10, we're going to factor out a -2. Now that right there is a perfect square trinomial, and a perfect square trinomial factors into two identical binomials. So don't forget to bring down the -2 and then x minus 4 quantity squared. Okay, now these problems are very similar to the problems on your worksheet. They're not on the worksheet, but they are similar. Square root of 72. We're going to list all the perfect square roots. Now what you want to try to find the largest perfect square that goes into 72, and that would be 36 times 2, which is 6 square root of 2. Example B, we're going to break down 18 to 9 times 2 and square root of 48 to 6 times 3. Square root of 9 is 3, and it comes outside, and we multiply it times this 3 and get 9 square root of 2. We're going to take the square root of 16 and get 4, and we multiply that 4 times 5 and get 20 square root of 3. Now, back to example A. What if you broke square root of 72 to 9 times 8? You would get 3 square root of 8. Well, 8 is not finished. You can break square root of 8 down to 4 times 2. Then you take the 4 out, square root of 4, and get okay, never mind. If we are multiplying two binomials together with imaginary numbers, we're going to do the FOIL method. Now remember, I squared is -1. So anytime you see I squared, you replace it with -1. Your 6's go away and you get -3i. You cannot have an imaginary number in the denominator, so we have to get rid of that by multiplying by the conjugate. The conjugate is the opposite, which is 6 plus 2 square root of, 2i. So we have to multiply top and bottom. So we're going to do the FOIL method in the numerator. Now, when you are multiplying by the conjugate and you do the FOIL method, you know the outside and the inside term is going to go away, so all you technically have to do is first and last. Remember, anytime you see I squared, you replace it with -1. Now simplify. You must simplify that 6 over 40 plus 22i over 40, which then you reduce each fraction. Okay, I to the 39th, we're going to break that down to I to the 38th times I to the 1 power. We're going to break the I to the 38th to I squared to the 19th power. Anytime you see I squared, you replace it with -1. And -1 to the 19th power is -1 times I is -I. Okay, number 23, we're going to do the square root property. The square root property is where you have to get the x squared by itself. Once you get it by itself, then you take the square root, and remember, you must give it plus or minus. Here, on number 26, we want to get the x minus 2 quantity squared by itself first. So we're going to subtract 4. Then we are going to divide by 3. And I want you to finish by taking the square root. And you should be able to finish this problem. Number 28, you have to do the quadratic formula. Here's the quadratic formula. Plugging it in. You simplify, you get 8 plus or minus the square root of negative 8i over 12. You have to simplify that to negative 4 times 2, that's 2i squared of 2, and then you need to, we would replace that, and then you need to separate it by putting 8 over 12 plus or minus 2i squared of 2 over 2 and simplify, and you can finish. That is the